Hi, welcome to the people joining. Hi, welcome. Hello, guys. Welcome if you're joining for the first time, or if you are a regular, then welcome to you too. I'm just setting up this quick poll for you guys so that you guys can decide which topic we'd like to cover first. We're going to do a bit of biology this morning. So have a look at the topics on the screen, have a think about which one is a topic that you perhaps need to work on, one that you need to revise. And I'm setting up a poll for you guys, so in a moment you'll be able to see it on your screen and you'll be able to tap on the one that you want to vote for, the one that we're going to start with. So hopefully I spelled all that right. Hi, welcome guys. Hello to everyone. Hope you're all doing well. Welcome to the live. If you are sitting there waiting to vote or waiting to, hi Susan, or waiting to get started, do tap on the screen, like the live so that other people know to join us as well, so that people know that we're revising. It does help to get people in here so we can get started faster. So yeah, if you are joining for the first time, welcome. If you've been here before, then welcome back. And yeah, whilst you're just sitting there, do like and let other people know that we are here. Yeah, I am getting through all my emails. I know I've got lots of requests and questions from lots of you guys, so I am trying to get through them as quickly as I can. Hi, Sarah. I'm okay today. Not too bad. Not too bad. Thank you. How are you? Welcome to the new people joining. Thank you for liking the live. Thank you for the follows. If you haven't yet followed, make sure you are following so that you don't miss out when we are doing these lives. And like I said, welcome to all the new people. Welcome to the people who are coming back. There is a poll going, so if you vote on the poll, I'll be able to see what the majority of you want to do as your first topic today. We're going to start off with biology. So the 4 topics of choice are enzymes, disease, animal hormones, and circulatory system. All very important topics. Yeah, I didn't sleep too well either, to be honest. But yeah, it is really important that you guys are getting good sleep, especially when you're revising so much. Remember that memories and kind of knowledge is consolidated in your brain when you get good sleep. So if you're not sleeping well, all of your revision will be going out the window. Yeah, I think it's the change in weather, the change in pressure. I think it's causing us all to get poor sleep. But yeah, make sure you are sleeping lots so that your knowledge of all your revision stuff is sticking in your head and so that it's not all flying out, because then it's all going to go to waste. Ella, is active recall good for science revision? Absolutely. It's extremely good for science revision. Active recall, trying to teach other people things that you've just learned, all really good. Thanks for the likes, guys. Do like the live as you're kind of waiting there for us to get started so that other people can join us and they know that we're live. It does help out. And if you're not following, thank you for the follows. If you're not following, do follow so that you don't miss out on our lives, okay? So make sure you're following. Is this things that will be in the GCSE paper? Yes, it is. Let's see how the poll's doing. Have you guys voted? I can see, enzymes are getting a big majority so far. Enzymes with the circulatory system second. So yeah, enzymes are quite a big topic. They always come up, right? So yeah, we're gonna do some revision on enzymes in a moment, so you'll see. So I'll ask you guys questions, but also go through the main things. So we're gonna go through them together. It does seem like enzymes is going to win. Thanks for the follows, guys. Thanks for the likes. Do like if you're just waiting there for us to get started. We will be getting started in a couple of moments. Just before we do get started as well, thanks for the follows, guys. For the new people here that haven't been on our lives before, make sure you check out this link at the top of my screen. It's also in my bio. Okay, this is where you'll find my GCSE 2023 maths and science predicted papers that I've spent so many hours making, literally over 100 hours making, including the mark schemes, to get these all out to you. And they're based off my predictions. The papers themselves don't take too long to put together because I'm naturally very good at making questions as a tutor, but the research into what kind of things should come up in this year's exams is what took so long. So these are the best things you're going to get, the closest things you're going to get to the real thing that you're going to be sitting in a few, several weeks. So really good revision for you guys. And if you're from my live, don't forget, when you're in the checkout section, if you type in live 30, okay, it discounts the papers a lot. So actually, everything's already discounted. When you type in live 30, it discounts the papers to like 60 or 70p per paper with the mark scheme. So it's really, really cheap. And you can also book yourself onto our lessons on my website too. Okay, but they're really, really cheap. They're literally 60 or 70p per paper, only because it took me so many hours to make these papers. Okay, it took me a lot of time. But because of that, I know I'm confident that these papers are the closest thing you're going to get to your real exams. So it does seem, just looking at the poll, there's 5 seconds left. 4, 3, 2, 1. Enzymes are the majority winners by far. So we are going to get started. Okay. The papers on my website, the GCSE maths papers, are for AQA, OCR, and Edexcel. The science papers are for AQA combined tier and higher tier. Okay, so good. I'm glad your brother uses the papers. So do check them out on my website, okay? And don't forget to use that code LIVE30, okay? If you use LIVE30, you're going to get 30% off everything which is already discounted. So all the papers will be like 60, 70p per paper with the mark scheme. So like I said, really good. Yeah, the website is Shopify. A lot of retailers use Shopify, so it's like every other retailer online. So let's get started. Thanks for the likes, guys. Thanks for the follows. If you're not following already, make sure you do follow so that you don't miss out on these lives. So let's talk about enzymes. So we should know that, firstly, enzymes are proteins, right? Like most things in the body, enzymes are proteins. They're made of proteins, and so they're made as a result of protein synthesis. And enzymes generally, we say that they are, hopefully you guys can see what I'm writing on the screen, enzymes are biological catalysts, right? So they're biological catalysts. And remember that catalysts are things which speed up chemical reactions. So these ones are speeding up the chemical reactions inside our body. Okay, so they're speed up the chemical reactions inside our human body. And another key thing here is they do this without being used up themselves. Okay, so without being used up. Okay, so enzymes don't actually get involved directly in the reaction. They simply lower the activation energy, so allow for the reactions to happen more easily without themselves being used up. Okay, they're made inside living cells, okay, as a result of protein synthesis, like I said earlier, and they're really important for all our metabolic reactions in the human body. Okay, so metabolic reactions, when we say metabolic reactions, we're talking about all the making and breaking of stuff inside the human body. Okay, so for example, the making of proteins from amino acids, the breaking of lipids into glycerol and fatty acids. All of these are examples of metabolic metabolic reactions. Okay, what example is the combined science? It's AQA, higher tier. Okay, on my website. So these papers on my website are AQA combined science and triple science higher tier. So those are enzymes, and enzymes are very specific. And this is actually a key feature, okay? Live 30 is the discount code, guys. The fact that enzymes are so specific is a really key feature of enzymes, meaning that each enzyme can only break down one type of substrate, okay? So each enzyme can only break down one type of substrate. And the whole reason for this is because the enzyme itself, okay, let's say this is my enzyme, looks a bit like a Pac-Man there. This enzyme has a very specifically shaped, what we call active site. So this bit here where the substrate's going to go in, this is the active site. And this active site is going to be a very specific shape, very specific 3D shape, and it's going to only be complementary to one type of substrate. And yes, like you guys are saying, these are the premises of the lock and key hypothesis, or lock and key theory. So what will happen is a very specifically shaped substrate, okay, like this, for example, will enter my enzyme's active site if it fits. So if it's complementary to it, the enzyme is going to break down this substrate, and therefore it will form two products, okay? and it's very important that these two are complementary, right? So what we would say here, there's a couple of key terms and key things to say when remember, biology is very picky about how you answer questions and what you write in your answers to get those marks. So the kind of things you'd want to be able to say here is that, firstly, it's complementary pairing. So they need to fit perfectly. That's the lock and key hypothesis. Complementary means that they fit together nicely. Okay, so for example, if I have this shape on my hand, my fist in my hand there, that's complementary, right? They fit in perfectly. And we also need to say that when the substrate goes into the enzyme, so when the substrate goes into the enzyme, let's say this is my enzyme again. Let's say my substrate is the thing that goes inside it, like this. Okay, this at this point here is called an enzyme substrate complex. And if you can mention this, especially if you're triple science students, your examiners are really going to like you. They're going to be like, wow, this person's got good knowledge. Okay, so this is called the enzyme substrate complex. Okay, it's equivalent to if you put a key in the keyhole and that key fits perfectly into that keyhole, at that point there, that's an enzyme substrate complex. Okay, so if you're triple science and you mention something like this, you will get marks for it. Okay, you will get marks for it, and your examiners will be like, okay, this person knows what they are saying. All right. Okay, so we're happy about that. So the enzyme and substrate will go in together and they'll form this enzyme substrate complex, which actually causes the substrate to break down, and then you get two products. Now, how does the substrate know to go into the enzyme? Can anyone tell me? How does the substrate know to go into the enzyme? Or vice versa, how does the enzyme know to get the substrate? Do they have brains? Is there anything telling them to go together? Let's see if anybody knows the answer to this one. It's a bit of a trick question. So not really. You'd think there's very good answers though. DNA, nucleus, you'd think there's instructions for it, but Juliet is the one that's correct there. Well done, Juliet. That's the first correct answer that I've seen. It's to do with collisions, okay? In a solution and in your cells and in your body, things move around randomly, okay? Things move around randomly, and enzymes and substrates coming together is just random, okay? It's a completely random process. So enzymes and substrates colliding is simply a random process. Okay, and that's why things like temperature will affect the rate at which enzyme and substrates work. Right, so it's all to do with collisions, like lots of you have said, so well done. Right, so with that in mind, like we said earlier, temperature is going to have an effect on how enzymes work, right? Because if we increase the temperature of a solution, the enzymes and the substrates will be moving around more rapidly, colliding more often. And if they're colliding more often, there's a greater chance that they're going to collide into each other in the perfect way for the substrate to be broken down. Okay, so that is key. However, we should also know that, so if we look at, let's actually write some of this down so you guys can take screenshots and notes of this as well. So we've just spoken a little bit about temperature, and we said that when we increase the temperature, so increase in temperature, right, this causes more kinetic energy, so more collisions, and so more substrate breaking down, right? So the enzyme activity is going up. However, what will happen? Can anyone tell me what will happen to an enzyme if I increase the temperature too much? So if temp is too high, what happens to an enzyme? If temperature is too high, I want to see one word. Well done, everyone. It is indeed the enzyme denatures. Okay, and what this actually means is the active site is going to change shape. Okay, so if my active site initially looked like this, remember my Pac-Man from earlier, if this was my initial active site and this fit a particular substrate perfectly in that complementary pairing that we spoke about in that lock and key hypothesis, right? Then now this is going to be a different shape. So now my Pac-Man might look a little bit different because the temp just kind of changed its shape. It's kind of broken it down a little bit. It's no longer like it should. It's now not going to fit my substrate. And so, or my substrate won't fit the active site. And so the substrate won't be broken down. Okay, the enzyme is no longer able to work as it should. So this is super important. And you can kind of, again, think of like the key, lock and key hypothesis, right? If you were to melt the lock or melt the key, they would not fit and they would not work. And it's the same with this, except the enzyme, which is the lock, is the one that's being melted down and is not working. Okay. Let's also remember that the denaturation, so the enzyme denaturing, is an irreversible reaction. It's irreversible, which means that once an enzyme denatures, okay, you cannot ever revive that enzyme. It can't come back to what it used to be. That enzyme will be broken down and a new one will be made. All right. So remember, it's irreversible. And that's really, really important. So well done. So we've spoken about the fact that temperature affects enzymes. Another thing that affects enzymes is the pH. Okay. So another thing that affects enzymes is the pH. And if the pH is either too high or too low, then again, the enzyme will denature. Because if the pH is too low, it's too acidic, it's going to break the enzyme down. If it's too high, it's too alkaline, again, it's going to break it down. Okay, so absolutely, pH which is too high or too low will denature the enzymes. But as with temperature, there is an optimum pH. There is a pH at which the enzyme works the best. Okay, and that's known as the optimum pH. Okay, so optimum always means the best. So optimum, there's an optimum pH, and there's also an optimum temperature, and so on. So good, we're seeing what is the ideal pH. It depends on the enzyme, right? So we have enzymes like pepsin in the stomach. Somebody's mentioned that one, very good, which is a type of protease. And pepsin, because the stomach is acidic, will have an ideal pH range of around somewhere between 1 and 3, usually around 2. So yes, but you have some enzymes in your mouth, right? You have amylase inside your mouth, and your mouth is more alkaline, right? So your mouth pH might be kind of somewhere around 7 or 8 or thereabouts most times. And so amylase is going to work better at those types of pHs. All right. No, pepsin doesn't neutralize HCl. Pepsin is a protease. It breaks down proteins. Okay. Maltase is a carbohydrate enzyme. It breaks down sugar, maltose specifically, into glucose. But good questions. Okay. What do you guys think as a question? Okay. What do you guys think as a question would be the optimum temperature of enzymes that work inside the human body? Optimum temperature of enzymes inside human body, so inside humans. Yeah, I'm getting really good answers. Well done. So most enzymes in the human body have an optimum temperature of about 37 degrees Celsius. Okay, so when we get ill, right, and we get a fever, which means our temperature might go up to 39 or 40, some of those enzymes will denature at those temperatures. Okay, and some of those enzymes are dying, which is why, well, part of the reason why we feel groggy and sick, because our body's just not working as it should. Okay, things that are running all the metabolic reactions in our body, the enzymes, are breaking down, the denaturing. And so we have to then create new enzymes to replace those via protein synthesis. Okay, so this is super, super important. And it's kind of nice to understand why all of this is happening. I've had a very good question from someone. ARU, very good question, because I forgot to say it. What happens if the temperature is too low? So if the temperature of the solution is too low, or inside your body is too low, what will happen to enzymes? Are they going to denature again? That's a question. What will happen to enzymes if the temperature is too low? Well, we said, yeah, they're not going to denature. Good. We said that if the temperature is high or optimum, then the enzymes are moving around rapidly. There's lots of kinetic energy. So yes, very nice. There'll be low activity. Okay, because there's going to be less kinetic energy, there's not going to be many collisions. Nice one, Holly. And so the chance of a substrate hitting into the active site, and therefore the enzyme breaking down that substrate, is going to be much lower. So the activity will simply decrease. Okay, and we can actually draw graphs for these types of trends, can't we? Right, we can actually say that, for example, for pH, right, we could draw a graph that looks a little bit like this. So let's draw it here. Okay, if this is my graph, we'd say, well, every enzyme will have an optimum pH. So the graph will look similar to this. Okay, with the optimum pH, on the y-axis you'd have activity, so how well it's working. On the x-axis you'd have pH. So this enzyme here might have an optimum pH of about 2. Okay, so this might be an enzyme like pepsin that we find inside the stomach. All right, with temperature, the graph looks quite different. Okay, though it's kind of a similar trend, it looks quite different, and that's because, remember, there's low activity when the temperature's low, but it's not completely zero. So for temperature, if we draw the same kind of graph, okay, very poor sketches, but temperature would be, remember, on the x-axis. This is just the title. Activity would be here on the y-axis. Temperature would be here. Okay, remember, with the temperature, there's low activity when the temperature is low. It will increase at the optimum temperature, and then it's going to drop back down, and it will drop back down much more rapidly than it did the rise on the left. Okay, the reason why it's dropping down rapidly on the right, over here, is because at this point the enzyme's denaturing. Okay, whereas over here on the left side is just low activity because of the fact that there's a low temperature, few collisions, and therefore less chance of the enzyme and the substrate fitting together. All right, so really, really good. We've got a question. Can you cover the 2022 papers? I think that's a good idea. I think that's something that we should do. We're not going to do that on this live, but we will do it, okay? I think it's a good idea to do something like that. I think it would be beneficial for a lot of people. So, these are the kind of main ideas surrounding enzymes. Do you guys have any questions about enzymes, firstly? Okay, yeah, we can have a go at those. Don't worry. We'll do them at one point. Samia, you have a question. Let's hear it. Is the optimum temperature the highest point on the graph? Yes. Very good question. This would be the optimum temperature, and this would be the optimum pH. So you kind of track it down and find out what that is. You track the temperature down and find out what this is. It might be 37. So just to clarify, enzymes denature if temperature is high and pH is low. So yes, but also when pH is high as well. So enzymes denature if temperature is too high and if pH is too low or too high. But good, Samia, good. Okay, let's quickly test you guys on some of the things that we've covered up to this point. Okay, so I want you guys to fill in the blanks, okay, as I speak. So I'll say some words and then I'm going to say blank, and I want you guys to fill in what that blank is. All right. So, firstly, enzymes are biological blank. Can anyone tell me what that is? Enzymes are biological blank. Good. Catalyst. Very good. And very good. Nice one, guys. Lena, Anna, nice. Next. And they speed up the rate of chemical reactions without being blank. So enzymes are biological catalysts and speed up the rate of chemical reactions without being blank. Yeah, very good. Nice one, Fraser. Nice one, Samir. Jack, good. Lovely. Okay, next one. Enzymes are inside all living cells, and they allow for all blank reactions to occur, which are important for human life. So enzymes are necessary to all living organisms, and they allow for all blank reactions to occur, which sustain life. Yeah, I'm seeing good answers. So we've got a mixture here. It's literally about 50-50 between metabolic and chemical. I was looking for metabolic, but chemical reactions, yeah, metabolic chemical reactions is also correct. So well done. Very, very nice. Okay, well done, everyone. That's really good. Next, we have enzymes have a very specifically shaped blank, which allows for substrates to attach. Enzymes have a very specifically shaped blank, which allows for substrates to attach. Yeah. Very good. Active site. Nice one, ARU. Nice one, Samia. Juliet. Perfect. Okay. Next one. Let's see if you guys remember this. Some of you were here, some of you were not. So if you remember this, great. If you don't worry about it. It's not something you need to remember. But let's see if you guys can. So I was saying earlier, when an enzyme and a substrate bind together, this is called a blank. When an enzyme and a substrate bind together, nice one. We've got an answer. Yep. Very good. Nice one, Caitlin. Nice one, dash dash. Yeah, Jack Robinson. Okay, some of you are listening. I like it. Lock and key model, good. Yeah, it's an example of the lock and key hypothesis. Very good. I like it. All right, next one. I was saying earlier something else. I said denaturation is a type of blank reaction. Okay. Denaturation is a type of blank reaction. It's a bit of a tricky one. Can anyone get this one? Ooh. Yeah, somebody's got it. Lula, Layla, Maddie, well done. Yeah, everyone's getting it now. Samia, Holly, good. Yeah, Anna, irreversible reaction, okay? When denaturation takes place, no, chemical would not be what I'm looking for here, okay? Because denaturation here, I was looking for irreversible, it cannot go back, okay? Chemical reactions can go back, okay? Some of them can. So if you've got a reversible chemical reaction, they can go backwards, right? But I was looking for the word irreversible. So well done. They cannot go back. Okay, and last one. You guys can give me one answer each or multiple answers if you know multiple reasons why this happens. So denaturation can occur due to blank. Denaturation can occur due to blank. Denaturation of enzymes can occur due to blank. Yes, nice one, dash dash. Fraser, Maddie, Juliet, Agua, Samia, Lee. Very nice. Okay, good. Well done, guys. That was very good. Yeah, I think that was very nice active recall. You guys did really well. I'm proud of you guys. Got a tear coming out my eye for all of you. Nice. Um, yeah, it was really good. So hopefully you guys have learned something there, and hopefully you've kind of built on your knowledge of enzymes a little bit. And if it's not building on knowledge, at least you've definitely done a little bit of revision on them, so you've got them fresh in your memory. Okay, so we will be doing more things like this in the future. Just another time for you guys who are new or who haven't yet checked this out, do check out the Gcse maths and science predicted papers on my website. As you guys know, my website link is christuition.myshopify.com, which you can find in my bio as well. And if you are coming from my lives, if you use the discount code LIVE30 in my website, all the papers which are already discounted on my website will get discounted even more by 30%. So I think each paper comes to about 60 or 70p with the mark scheme if you use this code as well. So it's a really good opportunity for you guys. Like I said, these maths papers are for AQA, OCR, and Edexcel. Okay, high tier. The science papers are for combined and for triple, combined and triple, so make sure you choose the right one, and the AQA. All right, so do check them out. I've spent a lot of time getting all of these done for you guys, and they're all basically the closest thing you're going to get to the real exams. Okay, I've done a lot of research into things that are going to be coming up on the real papers based off patterns and trends that you see, and also based off facts that certain parts of the specification must be covered within a certain time frame. Otherwise, the examiners have to, or the exam boards have to change their spec. Okay, so by actually looking into what's been covered in the past 5 years, or 4 years, I can predict what has to come up this year so that they don't have to change the specification. And yeah, no examining board wants to change the specification because it's a lot of work and it costs them a lot of money to do that. So they don't want to do that. So yeah, as a tutor, I've learned a lot of these trends and I can use these trends to help all my students like I do every single week because I have lots of students that I teach every day, but also I can help you guys out as well. How often am I live? I will be trying to go live every single day, Caitlin and Finn, and all the other people asking Poppy. I will be trying to go live every single day for you guys, and we'll try and master a topic every time. Hello, so do you know when the mark schemes would be released? The mark schemes have all been released. I think Shopify is taking its time sending them out. But if you haven't yet got because there was a bug initially, but if you haven't yet got your mark scheme, then let me know and I'll try and send it out to you manually. But I know lots of people have been asking, so I've been trying to do that. Okay, but now if you purchase the papers now, you should be getting all the mark schemes with it as well. You're very welcome. What time are these live? So currently there's no set time just because it's Easter holidays. So I tutor people throughout the day at random times when they need the lessons, when they've booked lessons in. So it's difficult to do a tight schedule. But if you're following me on TikTok, you will get a notification, or you should get a notification when I go live. So make sure you're following. Yeah, if you haven't got your mark scheme, they will be coming through probably sometime today. People have been messaging me saying, oh, I haven't got my mark scheme. Then, oh, yep, I did get it. I think Shopify has just taken a few hours to send them out, so don't worry, they will come through. The lives usually tend to be somewhere between half an hour to an hour, sometimes a little bit longer. So yeah, thereabouts. Okay, so yeah, if you guys have any specific requests for what you guys want to do in the next dive, message me on TikTok. Feel free to send me a message and I will collate these, and the most popular topics I'll put into that quick poll at the beginning so that you guys can check that out. All right, but yeah, like I said, if you're not following me already, make sure you're following so that you don't miss out on these lives. If you're new to this and this is the first time you've listened to me, go watch my videos, revise off my videos, do the quizzes, and boost your revision in that way. Hopefully you guys are finding this helpful. Hopefully this is not just for me, because that would be quite shameful, that I'm spending this time just for myself. So hopefully you guys are finding these useful. You are actually learning something, or at least you're consolidating some of the knowledge you've learned before. And yeah, no, it's a pleasure to teach you guys. So hopefully this is helpful. If it is, make sure you follow so that you guys don't miss out on these lives. Oh, thank you, Samia. Samia's a regular here. Oh, no, never mind. I'm sure I've seen a Samia or Samia before. Okay. It was your first time, so I'm glad you found it helpful. dash dash, the guy with the username that's like this, he's a very regular guy. He's always here and he's always answering all the questions, mostly correct. So he's done some good revision. Susan, you're very welcome. Anna, I'm glad you found it helpful. So that's good. I'm glad. So I'll see you guys again sometime soon. I'm going to go grab myself some breakfast. So make sure you guys have something to eat. Make sure you're not spending all day just revising, and make sure you guys get some good sleep, because sleep is when you have your memories and all your new knowledge consolidate and stick into your long-term memory. Okay, so make sure you guys are doing all of that, and keep revising, keep working hard. Check out my website if you haven't already. Don't forget to use the code LIVE30. Links in my bio. And I'll see you guys on the next live. So have a lovely day, guys. And I'll see you guys probably later today. All right. Take care, guys, and see you in a bit. You're welcome, Samir.